Hey everyone, in this video I'm going to show you how to build an HVAC system prototype using Quantum. HVAC is short for heated, ventilated air conditioning. We will be using a temperature sensor, a DC motor, a rotary encoder, an LCD display and 3 different colored LEDs. At the end of the video we will also be showing you a working damper and a plastic fixture for our control unit part. The HVAC system is simple. It is used to set the desired temperature. The temperature sensor is sending its measurement to the system. The app then decides if it has to start cooling with the fan enabled or heating with the fan disabled. Based on what the control unit is doing, the LEDs are representing the state. For example, when the system is cooling, the blue LED will be turned on and the green LED will indicate that the fan is operating as well, while the red LED remains off. Before we start making, please visit our website quantumintegrate.com, click Support in the top menu, then click Projects and Tutorials on the next page, scroll down and click Open Projects, and finally select HVAC System Prototype. On this page you will find all the related information for this project, like schematics, app and firmware files and much more. Let's have a closer look at the hardware components used in this project. I have an I2C LCD display, a DHT11 temperature sensor, a DC motor with an L293D H-bridge, a rotary encoder, 3 LEDs in red, green and blue, and a bunch of male-to-male and male-to-female jumper wires. All these components can be also found in our starter kit. Please refer to the Things Used in this Project section on the documentation page of this project for an in-depth view of all the hardware components and tools used, as well as information on where to get them. I will now follow the fritzing file and build the prototype. That was easy. Next, let's connect our builder bases with the Q server. First, make sure your builder bases are powered and are connected to the Q server or ready for pairing. Let's navigate to the Clients tab and pair our first builder base that is wired to the temperature sensor. Give that builder base a name and location. Next, let's pair our second builder base that is wired to the DC motor and the H-bridge. Give that second builder base a name and location as well. Lastly, let's pair our third builder base that is wired to the rotary encoder, the LEDs and the LCD display. Give that third builder base a name and a location as well. Now we have to prepare the firmware files for all 3. Before we start building the firmware this time, let's explore an easy way to figure out the address of the I2C display. If any device with an I2C field in its firmware is used, this technique can simplify the creation of it. First, make sure your I2C device, in this case our display, is connected to the builder base with power, ground, SDA and SCL. Then we navigate to the client page and click the Actions menu, click Debug, and in the Debug menu, we click the I2C scan button on the desired builder base. The actual address is shown in a banner on top and we can remember it for later. If your builder base is brand new out of the box, make sure to flash it with a random firmware file to make sure the I2C scan will work. If you've already used the builder base for another project, you don't have to worry about it. Now we navigate to the firmware page using the firmware icon in the menu on the left side of your screen. You can click Import and use the firmware file that we are providing on the project page or click Create New. For now, let's create a new firmware file together. Name it Temperature Probe and then click Create. Next, let's add some hardware to our firmware file. Our first builder base is connected to the temperature sensor. Let's add a temperature hardware and name it Temperature. Let's configure the temperature sensor. For driver, we select DHT11. For the pin, we select GP0. We set the resolution to 1 cm. Then click Save. Now, let's create the second firmware file for our other builder base. Name it Damper and then click Create. Next, let's add some hardware to our second hardware file. The second builder base is connected to the DC motor through the H-bridge. Let's add a DC hardware and name it Damper. Let's continue configuring the damper. Select H-bridge for the driver. Then select GP3 for the enable pin. For the DC1 pin, select GP2, and for the DC2 pin, select GP1. Finish by clicking Save. Finally, let's create the third firmware file for our third builder base. Name it Control Unit and then click Create. Next, let's add some hardware to our third hardware file. The third builder base is connected to the 3 LEDs, the rotary encoder and the LCD display. Let's add a forced air unit hardware and name it FAU. Continue by adding the LCD hardware and name it LCD. Next, add the rotary encoder and call it Rotary. Let's start configuring the FAU. We have 3 services that need to be configured. The first service is being used to indicate heating, which means it is hooked up to the red LED. Select the GPIO driver and GP0 for the pin. The mode should be set to initially low. Click the white arrow pointing to the right to switch to the second service. This service is for cooling, which means it is hooked up to the blue LED. Select the GPIO driver and GP1 for the pin. The mode should be set to initially low as well. Click the white arrow again. The last service is for the fan, which means it is hooked up to the green LED. Select the GPIO driver and GP2 for the pin. The mode should be set to initially low as well. Next, let's configure the LCD. Select generic LCD 2004 display I2C for the driver. Then enter 27 as the I2C address and select 2x16 for the layout. 27 was my result at the I2C scan, which was mentioned in the beginning of the firmware creation. Lastly, we need to configure the rotary encoder, which will be used to control the temperature set point. Select rotary encoder for the driver. For CLK pin, select GP5. For the DT pin, select GP4. For the BTN pin, select GP3. And for the BTN mode, select pull down. Congratulations, you finished creating the firmware files for the HVAC system. Now, all you have to do is upload them to the correct builder bases. Let's continue by building the application file for the HVAC system. Navigate to the app page using the app icon in the toolbar on the left side of your screen. You can either click Create New and follow the step-by-step description on the project page, or click Import and upload the application file that we are providing on the project page as well. First, let's revise the general structure of the app together. Looking at the canvas from a high level, you will notice the blue rotary encoder hardware object on the left. This is the hardware input we are using to define the set point. This value gets sent to a couple code objects that are counting the internal temperature value up and then save it as a persistent value using the database service, which is enabled by default. Below the rotary encoder, we have the temperature probe. This value is being used in multiple areas of this app. It is sent to a value compare code object to compare the current room temperature against the desired temperature. It is also sent back to the display using various code objects to display the current temperature. To the right of this, you can see the logic that is used to enable heating, which essentially closes the damper and turns on the red LED. The information is also sent to the blue LCD hardware object again. Above this group of objects, we have the logic to enable the cooling, which essentially opens the damper, starts the fan, and turns on the blue and green LEDs. The information is also sent to another blue LCD hardware object again. If you are interested in adding more zones or hardware, you can use this app as your starting point and use the various other objects to extend its functionality, purpose, and scope. Once you are happy with how your app is set up, click Save App, return to My Apps, and then click the Run button next to your app to begin the mapping process. We are using multiple LCD hardware objects in this app, but we will just map the exact same hardware to it. This is a convenient feature in case you need to reference your hardware areas of your app and don't want to draw across the whole canvas. When you are done mapping your hardware to the hardware objects in the app, click Save plus Run. And there you have it, your own HVAC system made with Quantum. This is just a basic version of the HVAC system, but the Quantum platform is capable of using more refined devices such as this one.
We hope you enjoyed this video. Check out the rest of our videos, remember to subscribe to our YouTube channel, and click the notification button for updates. You can also follow us on social media. Thanks for watching.